Welcome to Gradeful, where we provide online, one-on-one, live tutoring to students all around the world. If you're interested in finding out how we can pair you up with one of our Gradeful tutors to prepare for your next test, you can find our contact information on our YouTube homepage, just clicking About, which is what you're looking at here. You'll get to this page, which has our contact information. Also, if you feel like our videos have been helping you, you can feel free to hit the thanks button to contribute to the production of these videos. Right now, we're working on the March 2022 SAT QAS non-calculator math section, section 3. Let's go ahead and get right into it. On question number 1 here, we always want to start by describing our variables. So what's B? It is the number of electoral college votes that Blaine received. And what is C? It's the number that Cleveland received. Now, what does the question tell us? It tells us that the number of votes that Blaine received was 37 less than the number that Cleveland received. So the number that Blaine received was 37 less. Now, a subtraction has to go at the end. Subtraction implies an order. Something needs to be there for us to then subtract from it. So it's 37 less than the number that Cleveland received. And we're also being told that the two of them together, right here, it says the two candidates, Blaine and Cleveland, received a total of 401 votes. So if B is the number that Blaine received and C is the number that Cleveland received, then the two of them put together should equal 401. So looking just for that equation, we have it here and we have it here. So does our other equation match any of the answers? It looks like it's this right here is matching this right here. So the answer for number 1 is C. Going over to number 2 now, we can simply take away 2p from both sides. 6 equals 8 plus 5p. And now take away 8 from both sides. 5p equals negative 2. Now we can divide both sides by 5. And p is negative 2 over 5, which is B for number 2. Going over to question 3 now. We're hearing that m is a positive constant, and m is the slope. And slope is rise over run as you go from left to right. So if m is positive, then we know that as the equation goes from left to right, it's on its way up, like answer choice C and like answer choice D. And we also know that the y-intercept, the B, because this is just your classic y equals mx plus b equation, and we're seeing that the b part of that is a positive number. So between C and D, the one that has a positive y-intercept is this one right here. It's hitting the y-axis at a positive spot, and that's why C is the answer for number 3. Now we're looking at number 4 here. Let's zoom this in a little. Okay, so this equation is asking us to get h in terms of the other variables. So starting it out, we've got y is the square root of hg over x. So to get the h by itself, we're going to want to get rid of that radical. So let's do the opposite of a square root, which is squaring. So we've got y squared equals hg over x. And we're trying to get that h by itself. So what's happening to it? It's being multiplied by g and divided by x. So let's go ahead and do the opposite. Let's multiply by x and divide by g. So now we've got h equals x times y squared all over g, which looks like answer choice D for number 4. Now we're going to number 5. Number 5 is kind of quizzing you on the idea that if you have an absolute value equation, you have to know to split it into the two sides. So x minus 1 equals 8, x minus 1 equals negative 8, and solve each side. So x equals 9, x equals negative 7 when we add 1 to both of those. And so what's an answer for x minus 1? Well, here that would be 9 minus 1, so that's 8. And here that would be negative 7 minus 1, which is negative 8. So 8 and negative 8 are our two answers, and negative 8 is the one being offered to us. So that's A for number 5. Now, why did we split it into two? Just a quick word about that. What is absolute value? Absolute value makes something positive. So, for instance, if I had the absolute value of negative 5, that would turn it into positive 5. But if it was already positive, it would just leave it alone. So when we were solving an absolute value equation, we had to say to ourselves, okay, well, what if it were left alone? And what if it were flipped into the opposite sign? And if you're flipping something into the opposite sign, that really means that you're multiplying by negative 1, which is why we have 8 and negative 8. Going over to number 6. We've got a nice y equals mx plus b linear equation again. And looking at the slope, if I just pick two nice easy points, I see that our rise over run, as we go from left to right, we have it rising by 6 from negative 8 to negative 2, and running by 4. So the slope is 6 over 4. The y-intercept is the place where it hits the y-axis. This is the y-axis right here. Where is it hitting the y-axis? At negative 8. So the b is negative 8. So we've got y equals 6 over 4, which simplifies. So 3 over 2x minus 8, if you just put the m and the b where they go. So 3 over 2x minus 8 is A for number 6. Going over to number 7. Here we've got another y equals mx plus b type of linear equation, and we're looking for the cost for each phone survey. Now, this situation is a really interesting graph that is kind of a combination graph. So for instance, right here means that we're buying only phone, or we're doing only phone surveys and no mail surveys. And right here means we're doing only mail surveys and no phone surveys. Anywhere in between is like a combination. So here we're doing roughly 75 of each, or here we're doing 50 phone surveys and about 125 mail surveys. So for these combination graphs, what you really want to do is you want to look at the intercepts, because right here you'll have 125 phone surveys, and right here you would have 200 mail surveys. Now, just once again, in this situation, we have phone surveys and no mail surveys. In this situation, we have mail surveys and no phone surveys. That's actually really useful because we know the cost in every situation is 5,000. So in this one, we can say, well, if I had 125 of something, let's call it P for phone surveys, and that equals 5,000. So using that, we could find the cost of one phone survey. And that's what we're going to actually do. But just looking at this one, 200 mail surveys would have costed the same amount. So we could have also found the cost of one mail survey. But let's go ahead and calculate this out. Divide by 125, divide by 125. And if this is the non-calculator section, we have to figure out a way to do this. So 5,000 divided by 125, and 125 times 4 is 500. 0, bring down the 0, and we have a 0, and the answer is 40. So we used the y-intercept, which was the moment when we were only dealing with phone surveys and not dealing with mail surveys, and we used that and the total amount of money to find the cost of one phone survey. So the answer for number 7 is C. And now we're going over to number 8 here. When you have a negative sign outside of a parentheses, you're going to want to distribute that. That negative is like the number -1. So -1 times this, -1 times that, and -1 times that. And those three things are going to be -2x to the third minus 2x minus 1. And we'll bring everything else over. Now we can combine like terms. This and this, 5 minus 2, is going to be 3. So we'll have 3x to the third. Combining these two, we have -4x. And then combining these two, +1 minus 1 cancels. And so we have 3x to the third minus 4x, with the last two numbers canceling each other out because you got +1 and -1. And that is C for number 8. Now we're going over to number 9. Number 9 is asking us about two similar triangles. And we're being asked, what information would we need to prove that the triangles are congruent to one another? And if we knew that angle ACB and DFE were equal, so ACB is this angle, DFE is this angle, if those are equal, well, the funny thing is we already know those are equal because there's a rule for triangles that says that if two angles are congruent, if two pairs of angles are congruent, then the third pair of angles automatically has to be congruent. So this one, we already knew that. Going to the next answer choice, if BC and EF were equal, BC and EF, well, that actually looks pretty good because we've got angle, angle, side, and angle, angle, side, and they're matching up in the same order. That's actually our answer because there are 5 triangle congruence theorems that you should know. Side, angle, side, angle, side, angle, side, 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 angle, angle, side, and hypotenuse leg. So if you don't know those, go ahead and look them up. But here, we just saw that there was angle, angle, side, because when we lined up all the congruence markings, we had angle, angle, side, as you were kind of going in order around the triangle. And on this one, we had angle, angle, side, as we were going in order around the triangle. So these were actually congruent by angle, angle, side. That's going to be our answer. But just to test out C, just in case, that one is telling us that AC and DE are equal. So now we've got the order of side, angle, side, which is one of our theorems. But then on this one, we've got angle, angle, side, if we're looking that one up. So they both kind of match one of the triangle congruence theorems, but they don't match each other. So C is no good. And D is not right because we did find the information that proved them right. They were not originally known to be congruent just with 2 pairs of angles. These 2 triangles were similar when it first started because similar means you've got the same shape and different sizes. So let's go ahead and look at number 10 now. Number 10 is utilizing our rules that say that if you have the product of powers, so I've got 2 things of the same base and different powers and we're multiplying them, in that situation you'd add the exponents. But if you had the power of powers, so I've got a power and I'm raising that to a power, in that situation you multiply. So this situation right here is our power of powers. We need to multiply those numbers, and that would give you y to the 9 over 6, 9 over 8, apologies, because 4 times 2 is 8, not 6, of course. And now we need to bring over the y to the 1/8. So we've got y to the 1/8 right here. And this is the situation where you add 1/8 plus 9/8 is 10/8. And that can be simplified to 5 over 4. And now putting that in radical form, well, just real quick, if we're going to need that rule, let's talk about the opposites of both of our rules. The opposite of this rule is if you have a to the b over a to the c, there you'd subtract. And the opposite of the other rule is if you had that same a to the b, but you had the c root of that, there you would divide. So in this situation, it sort of matches this. And if we kind of move it in the same order, then this would be y to the fifth, and it would be the fourth root of that. So that's answer choice A for number 10. And this is a rule that you definitely should know before you go into any SAT, this set of rules rather, and also this set of rules. So let's go over to number 11. What is the value of sine 3 pi over 4? All right, well, this is a big first. They're actually asking us about the unit circle on the SAT. So if you're a tutor and you prepare students for the SAT, you need to know about this because we have not seen the unit circle on the SAT. And if you're in your pre-calc class and when your teacher explained how to do the unit circle and you just totally had no idea what they were talking about, then maybe you want to pay attention to this explanation here. Let's go ahead and draw out the unit circle. The unit circle is a unit circle. In other words, there's a circle with a radius of 1. The word unit means 1 in math. So let's go ahead and put a circle right here. And let's imagine that this circle has a radius of 1 all around. Now that kind of means that this point right here is the point 1, 0, 0, 1, and so on. But in terms of trigonometry, think of it like the hand of a clock that kind of goes around in this direction. And if that hand were to hit right, well, at the beginning it's 0. If it were to hit over here, that's pi over 2, so half of pi. Going the rest of the way around, that's 1 full pi. Then we have 1.5 pi. And coming back around, we have 2 pi. So this point right here, that could be 0 or 2 pi. And just like a clock, that hand can go around and around and around. So that same stopping point, it could be 2 pi, it could be 4 pi if it went around again, 6 pi if it went around again. And that's kind of the idea of the unit circle. But we now need to populate the areas along the unit circle. So I'm just going to put some arms going out this way in these 4 directions. And we're going to count around. Now the way we're going to count is we're going to stop at our sort of vertical and horizontal points and also at points along these lines I just drew. So we're going to stop here, 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 like this as we go around. And when we do these, they are pi over 4. So this is 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which simplifies to 1 pi, 5 pi over 4, and 6 pi over 4, which is 3 over 2 pi, 7 pi over 4, and last but not least, 8 pi over 4, which is 2 pi. Now, you need to draw a line on this side and this side of each of those middle lines. So we're doing that in all 4 quadrants. And now we're going to count in a special manner again. We're going to count the horizontal and perpendicular parts like we did before, but we're going to count the blues now and not those purple ones we did in the beginning. So we're going to count like this. Here, here, here. So we're counting all the ones we just added, but we're ignoring the pi over 4s that we did before. And we're going to go around counting like that. So let's delete all these marks. So we have 1 pi over 6, 2 pi over 6, which would simplify to pi over 3, 3 pi over 6, which simplifies to pi over 2, 4 pi over 6, which simplifies to 2 pi over 3, 5 pi over 6, 6 pi over 6 simplifies to 1 pi. 7 pi over 6. 8 pi over 6, which is the same as 4 over 3 pi. 9 pi over 6 simplifies to 3 over 2 pi. 10 pi over 6 simplifies to 5 over 3 pi. And 11 pi over 6. And last but not least, 12 pi over 6, 2 pi. So we've got the unit circle almost fully filled out there. And now we need to fill in the individual values. And it's really easy to do. There's just a little trick to it. Hopefully my diagram has enough space to show all of these, but there's an order when we do it. We're going to always be filling out 1 over 2, root 2 over 2, root 3 over 2. And we're going to do that for x's and for y's, and we're going to use some common sense. For instance, if we're in this quadrant here, x and y are positive. Here, x is negative and y is positive. X and y are both negative, and x is positive and y is negative. So let's start. So for the x's for this point, and this point, we've got 1 over 2, root 2 over 2, and root 3 over 2. And for the y's, we've got 1 over 2, root 2 over 2, root 3 over 2. And that's already, that's not quite enough, but in the other video we did where we talked about the concepts that came up on the March 2022 section 3, we did another unit circle, and I didn't fill out the whole circle. So here I'm going to want to fill it all out just in case someone really needs to know how to do this. So here in the fourth quadrant, we'll do 1 over 2 for x. Now we're just doing all the x values. Root 2 over 2. And for this one, root 3 over 2. And we'll do the y's. The y's are all negative here, and they start high and go low. So negative 1 over 2, negative root 2 over 2, negative root 3 over 2. And so we've got all our values. A little tight on that drawing there. But let's do the third quadrant. So the x's start this way and go out this way. And they're negative. So negative 1 over 2, negative root 2 over 2, and negative root 3 over 2. So we're just counting the same thing over and over again here. Just gonna, okay. So now we've got the y's. Negative 1 over 2, negative root 2 over 2, negative root 3 over 2. And last but not least, the second quadrant. So we'll start with the easy ones. The y's are positive and they just go straight up. So 1 over 2, root 2 over 2, and root 3 over 2. And now for the x values, those are... Actually, I just did the y values. Let's start that over. Backtracking a little bit here. Okay, so here we go. The y values, 1 over 2, root 2 over 2, root 3 over 2, and the x values are negative. Negative 1 over 2, negative root 2 over 2, negative root 3 over 2. Sheesh. So pre-calc, definitely one of the hardest classes you'll ever do in high school, right? So now we're looking for 3 pi over 4, and the rule is really simple. The sine values come from the y of each point. The cos values come from the x of each point, and if you want to get fancy, the tan is equal to sine over cos. So if I needed the tan of 11 pi over 6, I would take the y value of that point divided by the x value of that point. So this is actually really easy. If we need the sine of 3 pi over 4, we're talking about the y value of that point, which, if you can understand my handwriting there, that's root 2 over 2. And we're done. The answer for 11 is C. And hopefully at some point in the near future we could do a more in-depth explanation of the unit circle, because that's a difficult thing to explain when you're in a rush. Now let's go to number 12. Another of the more difficult questions in this section 3 here. So a little background here. If you've got a regular exponential equation, the important thing is the base of the x, this number right here. If it's less than 1 or if it's greater than 1, you're going to get two different types of graphs. If it's less than 1, you're going to get a graph that's going to kind of get closer and closer to 0, like an asymptote. If it's greater than 1, it's going to start low and it's going to go up to infinity. So now, what's a negative exponent? Because we've got negative x right here. A negative exponent means that something's on the wrong side of the fraction. So we can rewrite this whole thing. This is y equals 1 over 2 to the x power plus 1. So using that negative exponent, we're realizing that this is the situation that has the b less than 1. And so that would be if we had y equals 1/2 to the x. That would be, like I said before, something that generally looks like this. Now, what does it do to add 1 to the outside of any function like that? If you're adding to the outside of a function, that's a vertical shift. And positive is up and negative is down for vertical shifts. So this is just going to go up by 1. Doesn't make a lot of difference because we really didn't know where it was before because we don't have any numbers on this graph. But when you're graphing exponentials, you need to take advantage of the 0 exponent, because that's like your really good reference point. We know the general shape looks like something like this, but we need to know where this thing hits the y-axis. So when x is 0, that would give us y equals 1/2 to the 0 plus 1, and anything to the 0 power is 1. And so now we know that it's hitting at 2. So we're looking for a graph that looks like this, and hits when x is 0, hits the y-axis when x is 0 and y is 2. And that is right here. So, both of these graphs have the general look of what we want, but A is hitting at 0, 2, and B is hitting at 0, 1. So the answer for 12 is going to be A. Now looking at number 13, we've got 10 plants being planted, and that's going to increase by 140%. So that's a tricky little situation for a lot of people. When you're increasing or decreasing by a percent, let's say we're increasing or decreasing by a nice number like 5. You start at 100 and you go up by 5 or down by 5 from 100, and then you put them both in decimal form. Now, if we did the same thing for 140%, so going up by 140%, on the negative side, it's kind of difficult because it would bring us to a negative percent, which doesn't really exist, or not for this type of situation at least. But going up by 140, it brings you up to 240%. And in decimal form, that would be 2.4. So we're looking for the one that's got 2.4. The general format of an exponential is a times b to the x. A is where it starts. B is how it changes. And x is the number of times that all of this happens. So we know that this thing is changing by a factor of 2.4 because we talked about that. And this is where we want that number to be. And so the answer for 13 is going to be D. Going over to 14. So this is our f of x. And now they're asking us about f of x plus 2. And we talked about this a couple of questions ago, but I did it really fast because it was a question with a lot going on. So I'm really happy that there's an opportunity to talk about function shifts. Let's say we had y equals x squared, which is a nice parabola centered at the origin. If you add to the outside of that, so let's say we had y equals x squared plus some number, that's the opposite of adding to the inside, which would be like x plus 3 squared. If you add to the outside, that's a vertical shift, and vertical shifts are normal. In other words, positive is up and negative is down. So this would be up 3. If you add to the inside of a function, like here, we're taking x and we're replacing the whole x with x plus 3 on the inside, right where the x is. That's a horizontal shift. And horizontal shifts are not normal. They're backwards. So positive is normally to the right and negative is normally to the left. So this is backwards. Positive is to the left. So this would be left 3. Now, this is the same as if we wrote it in the f of x notation. This would be f of x plus 3, and this would be f of x plus 3. So now relating that to the question, when they say f of x plus 2, if f of x plus 3 is left 3, f of x plus 2 is simply left 2. So we're taking every point on this graph and we're going to move it left 2. For instance, this point goes here. This point would go here. Just picking some nice simple points. And so we can connect. Let's see. So if we're going left 2, 1, 2, and 1, 2, and 1, 1, 2. Okay, so just kind of drawing a mirror image, it's going to kind of do one of these things. And here, just kind of drawing a mirror image of what we already have. And maybe drawing this as a reference point, just going left from here, left 2. And it's going to kind of go up this way. So that's what f of x plus 2 looks like. It's this entire graph all shifted over by 2. So let's kind of color it in and make it a little more pronounced here. And they're asking us, what's the y-intercept? Well, you can see that function that we just drew is hitting the y-axis right here. I'm marking kind of one a little north of it, but it's right there. And that is the number 3. So our answer is A, 0, 3 for number 14. Now we're going to 15. 15 is telling us that we've got a linear equation with no solution. And we're being asked about another line that could be the other line in that equation that has no solution. But when we're talking about the number of solutions for 2 lines, that's a common theme for us over here at Gradeful. 2 lines can hit once if they have different slopes, never if they have the same slope, or all the time if they have the same slope and the same y-intercept. And that's something you should know by heart. Here, we're being asked about something having no slope, and like I said, that's where the slopes are the same, the slopes are equal. So let's find some information about the slope. We can do that by putting this into y equals mx plus b. Let's subtract 2x from both sides. 2y is negative 2x plus 2. Divide by 2, and you get y is negative x plus 1. So this is the given equation after we've solved it for y. And so if that is a y equals mx plus b, we just found out that the slope is the negative 1 in front of the x, and the b is the 1 at the end there. So we need to know which of the given equations has a slope of negative 1. And the way to really do that is to just go ahead and convert them all to y equals mx plus b. So in this one here, if we take away 2x from both sides, we have 2y is negative 2x plus 3, and then divide by 2, and we get negative 1x plus 3 over 2, and that is an mx plus b with a y-intercept of 3 over 2 and a slope of negative 1, and that's what we were looking for. We needed the same slope, and the other slope was negative 1, this slope is negative 1, and so the answer for number 15 is going to be D. Now we're going to 16. Here they're giving us a function of g of x, and they're saying give us g of 8, which basically means replace x with 8. So g of 8 is 2 plus 8 over 8. We're replacing x with 8. So multiply or add the numerator. You get 10 right there, divide by 8, and start simplifying. 10 over 8, if you divide by 2 over 2, you get 5 over 4. And that is our answer for number 16, 5 over 4. Going to number 17, we've got a line. What's the slope of a line that's perpendicular to that line? Well, yet another y equals mx plus b. The m is negative 8. The b is 7. And perpendicular slopes are negative reciprocals. They're not always negative, but to get from a slope to its perpendicular slope, you've got to multiply by -1 and take the reciprocal. So in our situation, we've got the slope of -8. Any number is itself over 1, so -8 over 1. Therefore, the slope of a perpendicular line, it means we have to multiply by -1 and get the reciprocal, flip it upside down. So it's positive 1 over 8, and that is our answer for number 17. Now we're going to number 18. The solution is an ordered pair. What's the value of x? So in other words, what's the x of the solution? So if we want to get x without doing as much work, we can just solve for y, or we can eliminate y. So let's multiply this equation by -3 and this one by +2. So we're going to multiply by kind of opposite numbers, keeping that y in mind. If we multiply by -3 here and +2 here, it's going to give us -6y and +6y in the y column. So let's go ahead and do that. -3x minus 6y is -33, and +6x plus 6y is 48 when we distribute that 2 fully in there. Now we have what we want, which is the y is canceling out. If we add straight down, it'll give us 3, it'll give us 3x equals 15. 48 minus 33 is 15. Divide by 3 on both sides, and you get x equals 5 for number 18. Now we're going over to 19. We've got the volumes of 2 prisms, and the length of the longest side of prism A is 6 meters. So what's the length of the longest side of prism B? Okay, so there's something really important that we don't get to talk about a lot for SAT. If you have 2 similar shapes, the sides, let's just say the sides are in a ratio of A to B. If that's true, then it means that the areas of the faces are also in a ratio of A squared to B squared. And the volumes, if the shapes are 3D and they're similar, are in a ratio of A cubed to B cubed. So that means that if we know the volumes, as we do here, A to B here, or A cubed to B cubed, is 96 to 12, we can take the cube root of each of those numbers to find the ratio of the sides. So if we're simplifying for the cube root of 96, to simplify that, you would want to know the basic roots of 96. Well, 96 is really 2 times 48. 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 2 times 3. And so the basic factors of 96 are 1, 2, 3, 4, 5, 2 to the 5th times 3. And simplifying that further, For a cube root, you're looking for groups of 3. That's what the cube root means. It means if we have a factor that occurs 3 times, then we can take it out. So that 2 to the 5th, that's really 2 to the 3rd times 2 squared times 3. So we've got one factor occurring 3 times. And the way to simplify this is you can just cross it out and put it on the outside, because that's what we were looking for, was groups of 3. What's left underneath? 2 squared times 3, 4 times 3, so 12. So this all simplifies to 2 cube root of 12. And that's really interesting. So the ratio here is 2 cube root of 12, and the cube root here is simply cube root of 12. So even though that looks complicated, it is the ratio of the side lengths. And what makes it easy is that we have cube root of 12 here and cube root of 12 here, and those are going to cancel each other when we put them in ratio form. So the ratio of the sides of A to B, once again, 2 cube root of 12 over cube root of 12. And the longest side of A is 6, and this is the one we don't know. So, like I said before, we can cancel those cube root of 12s, and that'll give us 2 over 1 equals 6 over x. Now we can cross multiply that. 2x equals 6 divided by 2, and x is 3. And that is our answer to this incredibly tough question. So we've got 2 really tough questions on this section 3. We've got this one and also the unit circle question. So going over to number 20 now. Here, we can solve this using the quadratic formula, or we can solve it using completing the square. I'm going to go ahead and model it both ways. Although, I will tell you, being sharp with completing the square is one of the earmarks of a great SAT performer. That's something you really want to be good at. Using the quadratic formula, you definitely want to know it by heart. Negative b plus or minus square root of b squared minus 4ac all over 2a. So that'll give us negative 10, so positive 10, plus or minus square root of negative 10 squared, 100, minus 4 times, now first of all, this is ax squared plus bx plus c. So a is the invisible 1, b is the negative 10, c is the 14. So minus 4a, which is 1, multiplied by 1 does nothing, so I'm not even going to write it, and c, which is 14. And then we have 2 times a. Once again, a is 1. Multiplying by 1 does nothing, so we won't write it. Simplifying a little, we have 10 plus or minus the square root of, now 14 times 4 is 56. So 100 minus 56 is 44 all over 2. Now that 44, that's really, okay, let's do that here. Square root of 44 is the square root of 4 times 11. And we did this on an earlier question, 2 times 2 times 11. On the last question, we were doing a cube root, so we were looking for groups of 3. A square root has an invisible number 2, so you're looking for groups of 2. So these 2's can come out, and you can put a single one on the outside. So square root of 44 is 2 radical 11. So you've got 10 plus or minus 2 root 11 all over 2. And now you can divide these 3 things. They all have a factor of 2, so you can divide them all. That would be 5 plus or minus root 11 all over 1, and lo and behold, 5 plus root n, so that n is 11. And that's going to be our answer to this question, 11. But let's go ahead and imagine we are doing it with completing the square. For completing the square, you have to know, once again, the b of a quadratic is that number right there, so it's negative 10. And completing the square is based on that. You need b over 2, b over 2 squared. b over 2 squared is what you add to both sides, and b over 2 is what it factors to. So if our b is negative 10, then b over 2, negative 10 over 2 is negative 5, and square that number, you get 25. So we're going to take the original equation, x squared minus 10x. I'm going to subtract the 14 over to the other side. And we're going to add 25 to both sides. That'll give us 11 on this side. And x squared minus 10x plus 25, that's BC factoring. The two numbers that add to negative 10 and multiply to 25 are negative 5 and negative 5. So that'll factor to x minus 5, x minus 5. So let's write that in. X minus 5 squared equals 11. If you take the square root of both sides, you get x minus 5 is plus or minus the square root of 11, because radicals always have a plus and minus. Even radicals have a plus and minus. Adding 5 to both sides, we have x is 5 plus and minus root 11. And the format is 5 plus root some number, so the n is once again 11. And that's our answer to this question. Thanks so much for joining us for this March 2022 SAT Section 3 Non-Calculator Math section. Grateful does online, one-on-one, live tutoring. If you'd like to be paired up with a Grateful tutor to prepare for your next test, be sure to let us know. And if you feel like these videos are helping us, feel free to smash the thanks button to help contribute to the production of future videos. Thanks so much, and have a great day.